Hey everyone, and welcome back to DevOps Corner. Today, we are doing a deep dive into one of the most fundamental pieces of Kubernetes networking, services. If you want to finally master how to connect your applications reliably inside a cluster, you are in the right place. And hey, if you get value out of this, please don't forget to hit that like button and subscribe for more content just like this. So here's our game plan for today. We're going to start with the why, the core problem that makes services so essential. Then we'll introduce the solution itself and get our hands dirty with some YAML, breaking down the three main types: ClusterIP, NodePort, and LoadBalancer. And we'll finish up with a super simple guide on how to choose the right one for your needs.
All right, first things first, before we can appreciate the solution, we have to really understand the problem. Why are direct connections to pods such a bad idea?
Well, here's the thing about pods. They're designed to be temporary or ephemeral. They can crash, they can be scaled up or down, they can be rescheduled to different nodes, and every time that happens, they get a new IP address. So that brings up a huge question. How do you build a stable connection to something that's constantly changing?
And this is the real headache Kubernetes networking has to solve. Pods just aren't permanent. So if you hard-code your front end to talk directly to a backend pod's IP, that connection is, well, it's guaranteed to break. It's not a matter of if, but when that pod gets replaced. So what's the fix? How does Kubernetes solve this messy situation? The answer is actually pretty elegant. It's an abstraction layer called a service, and it's designed to give you a stable network identity on top of all those dynamic pods. A service is basically a single logical endpoint. You can think of it like a permanent address and a DNS name that sits in front of your group of pods. Even if the pods behind it are churning like crazy, the service's address stays the same, giving you one reliable point of contact for your application. Okay, enough theory. Let's get our hands dirty and look at the first and, honestly, the most common type of service, the ClusterIP. As its name kind of gives away, this one is all about communication inside the cluster. Let's break down the YAML.
All right, here's a look at a basic ClusterIP service in YAML. Now we've set the type to ClusterIP here, but fun fact, that's actually the default. So if you leave the type out, this is what you get. This setup makes the service reachable only from within the cluster, which is absolutely perfect for things like microservices talking to each other.
Now this is where the magic happens. Look at that selector field. We've set it to app nginx. You can think of this as a kind of matchmaker. The service is constantly looking around the cluster for any pods that have that exact label, app nginx, and it automatically starts setting traffic their way. Okay, let's zoom in on two fields that trip up everyone at first: port and target port. The port is what the service itself exposes inside the cluster. That's the port other pods will talk to. The target port, on the other hand, is the actual port your container, in this case nginx, is listening on inside its pod. They don't have to be the same, which is super flexible. So ClusterIP is awesome for internal traffic. But what if you actually need to get to your application from outside the cluster? Well, for that, one option is the NodePort service type. And here's the YAML for it. By setting the type to NodePort, we're telling Kubernetes to do something really specific: open up a static port on every single node in the cluster. It's a really fast way to get external traffic in, which makes it great for development or testing. But you probably wouldn't use it for a serious production app.
Now, that node port we specified, 3000-7000, has to come from a specific range, which by default is 30,000 to 32,767. And hey, if you don't feel like picking one, just leave it blank, and Kubernetes will grab a random one for you. Then you can hit your service by using any of your node IPs on that port.
For real production environments, though, especially in the cloud, you're going to want something way more robust. And this is where the load balancer service type really shines. The load balancer is pretty much the gold standard for production apps running in the cloud. And what's wild is how simple YAML is. I mean, look at it. You basically just change one line: type load balancer. That's it. So what kind of voodoo happens when you apply this simple YAML? Well, it's not magic, but it's close. Kubernetes tells your cloud provider, whether it's AWS, GCP, Azure, you name it, to automatically spin up a real external load balancer. This new load balancer gets a public IP and is automatically configured to forward traffic to the NodePort and ClusterIP services that Kubernetes creates for you under the hood. It's the whole package.
Okay, so we've got ClusterIP, NodePort, and load balancer. 3 types. How in the world do you know which one to pick for the job? Let's make it really simple with a quick comparison.
Let's just boil it all down. For any communication that stays inside your cluster, like a backend API talking to a database, you use ClusterIP. It's your default go-to choice. If you need quick and easy external access for development or testing, NodePort is your friend. And finally, for any serious production application running in a cloud that needs a stable public IP address, it's LoadBalancer, hands down. At the end of the day, Kubernetes services handle the tedious how of networking. They give you a stable, reliable abstraction so you can stop worrying about IPs and focus on the what, your actual application. Now that you've got the YAML down, the only question left is, what are you going to build? And that's our deep dive into Kubernetes services. I really hope this explainer helped clear up this super important piece of the Kubernetes networking puzzle for you. If it did, please do me a huge favor. Hit that like button, share this video with your team, and make sure you're subscribed to DevOps Corner for more deep dives into the tools we all use every day. Thanks so much for watching, and I'll see you in the next one.